When students face a wall of passive information, the results are predictable. Motivation drops, interest fades, and emotional burnout sets in. Over the next 5 minutes, we are going to change that. We will build an active lesson blueprint designed to turn a standard lecture into a process of discovery. Take a blank piece of paper, draw a line straight down the middle and another across the center, creating 4 distinct boxes. Filling in this final quadrant gives you a concrete framework for building lessons that students actually want to lean into. Box 1 is where you anchor abstract theory to the student's reality. This involves linking your topic to their future careers, other academic disciplines, or specific cultural touchstones. In a geometry lesson, you can bypass abstract formulas and instead ask the room to calculate the exact incline required to build the Cheops pyramid. For an economics class, you can illustrate business cycles using the specific headlines and data from the 2008 financial crash. Box 1 acts as an immediate justification for the lesson. It validates why the material is worth the student's time and attention. In Box 2, you identify a specific portion of your lecture to replace with a problem the students must solve. Problem-based learning is one option. You provide a scenario where the students lack the necessary information, which forces them to research the missing data themselves. You can guide this research using the 7-step Maastricht process. It provides a cycle for defining the problem, brainstorming, and identifying specific learning goals. Alternatively, a case study allows students to apply what they already know to a new, complex situation. Biology students, for example, could be tasked with selecting a specific list of plants that would survive in a local flower bed based on soil and climate data. Completing Box 2 ensures the students are participating in the discovery process, rather than watching it from the sidelines. Box 3 focuses on classroom dialogue. To keep the room engaged, you need to pre-script specific questions. Convergent questions check for factual understanding and have one correct answer. For instance, what are the 3 stages of photosynthesis? Divergent questions are open-ended prompts with multiple valid answers, such as, what would happen to the local food chain if photosynthesis worked differently? Relying solely on convergent questions often stalls a discussion as soon as the right answer is given. Divergent questions lower the stakes of the conversation, allowing students to suggest ideas and test their logic without a fear of being wrong. Box 3 ensures the lecture is a shared investigation between you and the room. Box 4 is dedicated to the support environment and the tools required to complete the task. According to cognitive load theory, complex problems can overwhelm students if they are introduced too early in the learning process. You can mitigate this by reviewing worked-out examples together before asking the students to tackle a problem independently. In this box, write down one digital tool the students will use to present their findings. A nonlinear mapping tool helps visualize complex relationships, while a collaborative slide deck is often better for real-time group organization. Box 4 ensures that students have the psychological support and the technological means to work together effectively. Look at the completed paper in front of you. You have a repeatable structure for your next lesson. You've established a real-world hook, an active task, a set of scripted questions, and a collaboration plan. Applying just the first 2 boxes in your next class will noticeably change how students interact with the material. This blueprint ensures that your students are the ones doing the heavy intellectual lifting in the room.